So the good news is today, in terms of information, we have really learned it all. So what we want to take time to do is sort of put it all together and summarize it. How can we kind of talk about all this information that we've learned and look at what that means tied together? So our objective today is really going to be to look at linear, quadratic, and exponential functions and talk about all the different ways we've looked at them over the course of the entire algebra curriculum. So not just this trimester, but all of the curriculum together. So I'm actually going to take a sheet of paper and turn it sideways. Okay, and I kind of want to look at three categories here. So our three categories, I'm going to zoom in a little bit, right, are going to be linear, quadratic, and exponential. Okay, and we have looked at these this year in multiple different ways. Okay. So one of the ways that we have looked at linear, quadratic, and exponential functions is that we've talked about the idea that we can look at these as a graph, right? We have spent time graphing each of these types of functions. Okay, and we have seen as we go through those different types of graphs that they all give us different types of pictures. Okay, so we have learned if we are graphing a linear function, we are always going to get something on the coordinate plane, right, that is a line. The line might go uphill, the line might go downhill, but either way we put it, when we graph it, we are going to get a line. Okay, we've looked at graphing quadratics in multiple formats. Okay, and no matter what, every time we've graphed a quadratic, no matter what format it is in, it has given us this U-shaped graph, right? That is a parabola. It might open up, it might open down, but it's still a parabola. Okay, and then most recently we have looked at graphing exponentials. And it might open up and it might open down, but no matter what, right, we're sort of getting this, what I call like this swoop shape, right? That sort of uphill climb as it's going up. Now, it could go up, it could go down, okay, but still that general shape. So we should know that if we see a graph and the graph looks like a line, it's definitely a linear function, right? If we see a line and it looks like a U-shaped parabola, then it's definitely a quadratic, right? We know that those are characteristics of those types of functions. Okay, we have also looked at the equations of these functions. Okay, and we have seen some things to be true about the equation at all times. So, for example, we know that a linear equation, while it could be in standard form, point-slope form, slope-intercept form, we always know that we have an x to the first power. We can't have an x squared. We can't have a negative exponent, right? It's always x to the first power. So it's always something like y equals mx plus b, right? ax plus by equals c. Now we could do rearranging to get it into that form, but that x to the first power. Okay, we know that anytime we are looking at a quadratic, in some way, shape, or form, we are going to have an x squared in the function. So whether that's happening with parentheses of something, right? Or whether that's happening in standard form with something, we know that in some way, shape, or form, right, that squared is going with the x. And we know in an exponential function that the exponent is the x, right? So our y equals ab to the x plus c. So if we are looking at an equation and we see an exponent that's an x, we should immediately think, oh, that's definitely an exponential function. We know that those are characteristics by how we see the variable and what exponent it has. We have also looked at these with word problems or story problems. Okay, so we should be able to associate words with these. Now, words with quadratics were a little bit unique because we were plugging that into a form. So there's not necessarily a key piece we're going to put in that column. But there were some words that we've definitely noticed when we are looking at linear and exponential. Okay, so linear functions have to have a constant rate. And we see this when we see that something is happening per item, right? It's $4 an hour, right? $4 per hour. Okay, we know when it's $12 per shirt, right? That's our constant rate. That slope is being the same. Whereas in an exponential function, we have a constant factor. And this was always something then that we could turn into a percent. So most of the time we just saw a percent, right? But it might say something like half, and we know that we could turn that into a percent. Now, we also have looked at these with tables and graphs, and that's going to require us to do a little bit of extra explaining with that. So I'm going to start on a fresh sheet of paper here. Okay, so we can also decide if something is linear, quadratic, or exponential when we're just given some points or values on it. So let's say we are given 3, 7, 4, 9, 5, 11, and 6, 13. Okay, my suggestion is that we always turn this into a table, or we plot them on a graph and we see if it makes one of these shapes. Okay, but if we are looking at a table, just because that's the one we haven't talked about yet, so I'm going to turn this into a table. And I'm literally, right, we should just know, we can just write our ordered pairs into this. Okay, and as long as these values are increasing by 1 over here, we can just count the distance between each of our y values. So from 7 to 9 is plus 2. From 9 to 11 is plus 2. From 11 to 13 is plus 2. If this is a constant value that is being added, okay, that's a constant rate. So when these numbers are all the same, we know that this is a linear function. Okay. Let's say we are given 3, 9, 4, 16, 5, 25, and 6, 36. So again, my recommendation is that we are going to turn this into a table. Okay, so same idea. I'm going to check over here. So 9 to 16 gives me a plus 7. 16 to 25 gives me a plus 9. 25 to 36 gives me a plus 11. So this is not linear because these numbers don't all match. Okay, so I'm going to do this again. So now I'm going to take the values I got here and I'm going to add again. So from 7 to 9 gives me a plus 2. And from 9 to 11 gives me a plus 2. So now I'm getting it to match on the second time out. Okay, the first, the second. When it matches in the second one, we know that this is quadratic. That's our exponent of 2, which is why it matches on the second time. Now, you could do process of elimination and say, okay, if it doesn't match the first time and it doesn't match the second time, then it must be linear. That's a totally valid option of something you could do. Okay, but let's just say I'm going to go ahead and give this to you straight in a table because sometimes we will just be given a table to start with. Okay, so if we don't see them matching the first time or the second time, which we could check, then we could say, oh, well, now it's not either of them, so it has to be exponential. But that's just because we only know 3 right now. The way to really verify is to see, okay, is there a multiple? Is there a factor? Okay, so 1 times what gives me 3? Times 3, times 3, times 3. Now, if you're like, oh, I'm going to be terrible at finding that, you can just set these up as fractions in your calculator. So do 1 over 3, which equals 1/3, right? Then do 3 over 9, which equals 1/3. And then do 9 over 27, which equals 1/3. So if when you divide them every single time, you're getting the same value out, that is what is going to tell us that we have a linear function. Okay, so when we are looking at these examples today, we're just gonna try and look and see. So if I give you something and I say, okay, is this linear, quadratic, or exponential? Don't like overthink this process. If you see a graph and it looks like this, you go, oh, that's a line is linear. Oh, that's a parabola is quadratic. Okay, if I write down an equation, so if I write y equals 2 to the x, oh, that has an exponent of an x, so that's exponential. The only ones that you have to sort of do some work on to decide is when we're given those tables are ordered pairs.